Welcome to another section of this program. I'm Adeka Solomon. Today we'll be dealing with permutation and combination. And when we talk about permutation, we are talking about different ways of arrangement, and we are talking about combination. We are talking about selection. So at the end of this video, I expect you, the viewers, to state the meaning of permutation. One, two, to state the meaning of combination. Three, to explain the difference between permutation and combination. Four, to use permutation and combination to solve a problem. Most people don't understand what permutation and combination is because when I went out to teach, and most students who were preparing for JAM and other exams were, when I asked them subjects that they find themselves, the topics they find themselves very difficult, and most of them mentioned permutation, combination, matrix, differentiation, integration. But in this video, we'll be dealing with permutation and combination. And when we talk about permutation, like suppose we are interested in the number of different arrangements of three men, and let's say the men, let's label them as A, B, and C. So we know that we have six ways of arranging that. But when it comes to the example, I'll explain better and you understand what I'm talking about. I can apply permutation in different ways. Like for you, the sports people, or football fans, let me say, if we if you goes to Premier League, we have 20 clubs. And the 20 clubs now, if they are playing matches home and away, how many ways they can make the arrangement, how many matches will they play? And that is the work of permutation. In this very video, I will focus more on permutation, and my second video will focus on combination. So permutation, if you go to the House of Assembly, maybe if they are sitting on a round table, the permutation will tell you how the sitting arrangement is. When we talk about the circular way in a round table, that means since we are talking about the circular, we don't have a beginning and the end, so one person will be fixed and you permutate to the rest. So stay tuned, don't forget to subscribe to my YouTube channel, Adeka Mathematical Solutions. You can follow me on Facebook and Instagram, Adeka Mathematical Solution. And don't forget to share my videos. There are some people there that will need the video, will be very useful to them. Don't forget to share for more updates. Thank you for watching. Okay, so when we look at this permutation now, we say suppose we are interested in the number of different arrangements of three men in a line. In order to be able to distinguish between the three arrangements, let's say we label them A, B, and C as I earlier mentioned. And when we label them A, B, and C, we have something like this: A, B, C. And what are the ways of arranging this? If you have A, B, and C, the different ways of arranging A, B, and C, the different way of arranging A, B, and C will be A, B, C. And another way will be A, C, B. So another way again will be B, A, C. Another one will be B, C, A. Another one will be C, A, B. Another one will be C, B, A. So if you look at this, the possible way of arranging this, we have 1, 2, 3, 4, 5, 6. That means we have 6 possible way of arranging this. There is 6 ways. And the 6 ways now we can say that is equals to 3 factorial. Okay, so we have 6 ways, as I said, ways is equivalent to 3 factorial. And 3 factorial, this 3, this thing that is I upside down is called factorial. So the 3 factorial is equals to 3 times 2 times 1, which we say 2 times 3 times 2 times 1 is equals to 6. That's why we have 6 ways. And to use the practical aspect, you see that we have 6 ways. And when you use this, you still discover that we have 6 ways. So that is what we have in this thing. So let me say in general, in, in general, the number, the number of different arrangements of of n different, let me say n different objects is equal to the products the products products n times n minus 1 times n minus 2 times dot times 4 times 3 times 2 times 1. And in factorial, this is what we call factorial. And I will give you examples in solving factorial. And when we talk about factorial, there are things that I would like you to understand about factorial. When we have 0 factorial is 1, and 1 factorial is equals to 1. So when we are solving something that I made mention of that, don't be confused. So now we look at the examples of factorials. So examples, find the permutation of the following. We have 5 factorial, 4 factorial, 6 factorial, 1 factorial, 0 factorial. So solution, solution of A, when we say 5 factorial, 5 factorial is equals to 5 times 4 times 3 times 2 times 1 times 0 factorial. Okay? So that will be 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So, and we say 0 factorial is the same thing as 1. So 0 factorial is 1. So here will be 120 ways. So let's say the B part, we have 4 factorial. 4 factorial is equals to 4 times 3 times 2 times 1. So no need of putting the 0 factorial, which will be 4 times 3 is what? 12. 12 times this, it will be 24 ways. So you can try this C part, 6 factorial, you can do that. Then which D, we have 1 factorial, which 1 factorial is equals to 1 times 0 factorial. And when we have 0 factorial is same thing as 1, so 1 factorial is equals to 1. So the E part, when we have when we have 0 factorial, as I've been mentioning, 0 factorial is equals to 1. So as this one is equals to 1 as I said. Now we look at other permutations. In general, if an operation can be, let's say if an operation can be performed in P ways and another operation can be performed in Q ways, then the number of different ways of performing the two operations one after the other will be say P times Q ways. Since I don't want to write it down, but you can read it as I'm saying, like a kind of detecting to you. So when we have something like that, I will give you an example because in mathematics, I believe examples explain better than all the grammars and all the speaking. So most of the things I will not be doing the writing, I will be talking. Then when it comes to the example, I explain the examples where. So now let's move to the example when we have P times Q. When we have P, when the P perform an operation and when the Q perform an operation, and we say the operation is P times Q. So I'll give you the example and I know you understand better. So example, suppose we are only interested in the number of ways the first and the second position can be taken by four people in a race, assuming there is no tie. So now we are talking about the first and the second position to be taken can be taken by four people in a race, assuming there is no tie. So let's look at the solution. This is when we are talking about P and Q, and let's look at the solution here. And the solution we say, without speaking much grammars, let me just be detecting. And when it comes to the solving itself, I say the first position can be taken in four ways by any of the athletes because we're talking about race. So the first position, the first position can be taken in that is in four ways by any of the athletes. The second position can be taken in three ways by the remaining three athletes. So the number of ways the first and the second position can be taken will be when the first one take, as in we have four athletes. So when the first one we take, then it will remain three. The first one we take four ways, then it will remain three. And the three, the second one we take. So this one, when they four now, when you take the first one now, it will be four, which is your P. And when it takes, it will remain three. And when the second one take, it will be this. So it will be four times three. That is the four for the first one and the three for the second athlete. So we have 4 times 3, which is equals to 12. But using the permutation here, we can say we have how many? 4 people. So this is the 4 objects. That is to be 4 permutation. 2, because we're talking about the first and second position, and this we call it permutation. And this when we are talking about this is the permutation of objects taken at a time. There is the permutation of object taken at a time. That is 2 will be taken at a time. So when we have 2 permutation, 4 permutation 2, it will be written as 4 factorial all over 4 minus 2 factorial, which will give us 4 factorial all over 4 minus 2, it will give us 2 factorial. And in the other examples, as we have been solving, we said 4 factorial is the same thing, is equals to 4 times 3 times 2. We stop here and we say 2 factorial all over 2 factorial. Since the thing has not reached 1, so here it will be 2 factorial and here will be 2 factorial. So this 2 factorial will go with this one. So it will be equals to 4 times 3. which it give us how many ways? 12 ways. So when we look at all those things, we discover that permutation is very, very simple. Most people find it very difficult. I When you watch this video, you can pause it, study it on your own. I will give you more examples. You practice, and I swear you enjoy it. So continue. Like let's continue in more examples. So here example, find the permutation of the following: 1 4 permutation 4, 2 5 permutation 2, 3 10 permutation 3, 4 20 permutation 10. So here we look at the solution, and the one now we say 4 permutation 4. 4 permutation 4 is 4 factorial all over 4 minus 4, or factorial 4 permutation 4. We have 4 factorial, 4 minus 4 factorial. So which is equals to 4 factorial all over 4 minus 4, it gives you 0. That is 0 factorial. And if you remember, in our initial example, we say when we have 0 factorial is equals to 1. So 4 factorial now will be equals to 4 times 3 times 2 times 1. And the 0 factorial is 1. So all will be divided by 1. And you still have 4 times 3 is what? 12. 12 times 2 is 24. 24 times this is 1. That is, we have 24 ways. So we look at example 2. So at example 2 now, we say 5 permutation 2. And 5 permutation 2 is equals to 5 times 4 times 3 times 2 times 1 all over 2 times 1. Some people will prefer doing it this way. Like this times this is the same thing. This times 2 times 1 is 2, and this. But me, I prefer saying this is equivalent to 5 times 4 times 3 times 2 factorial, so that the 2 factorial will cancel itself. If we use this thing, you do it this way, you get the same answer. You do this way, you get the answer. So 5 times 4 is what? 5 times 4 is 20. 20 times 3 is 60. So here we have 60 ways. But when you do this one, you say 5 times 4 is 20. 20 times this is 60. 60 times 2 is 120. So here will be 120 divided by 2. And 120 divided by 2, it will give you 60. So it will be something as 60 ways. But in the situation where sometimes you have the denominator will be large, maybe like in this example, you have 20 permutation 10. And for you to say 20 times this times 20 to 1, and for you to start saying 10 times 9 times 8 times 7 times 6 times to this thing, it should take much time. So when I'm giving most of my examples, is to help people, even help even in the exams, to like minimize your time, so that it will not consume your time, so you can stop at 10 factorial, and so that the factorial 8 will cancel itself. So I will move to example 3. Example 3, which we have 10 permutation 3, which is the same thing, is to be equals to 10 times 9 times 8 times 7 times 5 times 7 times 6, yeah, times 5 times 4 times 3 factorial all over 3 factorial over 3 factorial. This, okay? I'm sorry, I'm doing a mistake here. Now somebody not even corrects me. Okay, from here, the mistakes have 5 permutation on this. So this will be, oh sorry, here will be 5 minus 2 factorial. So here now it will be 5, 5 minus 2. I'm sorry, let's correct this mistake from the number 2. 5 permutation 2 is equals to 5 factorial all over 5 minus 2 factorial, not over 2 factorial. So from here we have this maybe all over 3 factorial. 5 minus 2 to give you 3 factorial. So here will be 3 factorial. And this 3 factorial, here we have not 60 ways. I'm sorry for the mistake. Here will be 5 times 4 times 3. 5 times 4, it will give us what? 5 times 4, it gives us 20, 20 times. And here is 3 factorial. So here, it give you 2, 5 times this, it give you 3 factorial. I'm sorry for the mistake. So here, it will not be 2 factorial, but it will be 3 factorial. So this 3 factorial will cancel here. It will give you 20 ways. I'm very, very sorry for that. So when it comes to this, we have 5 times this times 3 to this. And here it will be 2 times this. Pause. So here it will be 5 minus this. So here now it will be 5 times 4 times 3 times 2 times 1. And it will be, when you multiply this, you divide by 3. 3 times, here now it will be 3 times 2 times 1. So it will be 5 times 4 is 20. 20 times 3 is what? Is 60. 60 times this, it is 120. So 120 now here is this. So it will be 120 all over 6, which will give us 20 ways. So I'm sorry for the mistake. So here we have this, and this is 10. Here it will be 10 minus 3 minus 3 or factorial. So here it will be times 2 times 1. So here will be equals to, here now when you do this, you have 7 factorial. So let's do it this way: 10 times 9 times 8 times 7 factorial, because 10 minus 3, then it will give us 7 factorial. So here now it will be 7 factorial. So here will be over 7 factorial. So this 7 now we cancel this one, and we have 10. So when you multiply 10 times 9 times 8, 10 times 9 is equals to 90. 90 times 8, it gives you 720 ways. So if you have your calculator, you can try that. So let's try this number 4. Let's do this number 4. And number 4 now we says 20 permutation 10. When you say 20 permutation 10 is equals to 20 times 9 times 8, 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 factorial. So it will be all over 20 minus 10 of factorial. So which will be equals to 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 factorial over 10 factorial. Because 20 minus 10 to gives you 10. So here factorial. So this 10 factorial will go this. So when you use your calculator and multiply this by this by this, then you arrive at the answer. You can do that on your own. So here, hence, let me say hence, in in general, hence in general we can say n permutation r will be given as n factorial or over n minus r or factorial. So when we have this, it can be said is this is the permutation the permutation of n of n objects, the permutation of n objects taken at r, taking r at a time, at a time. So when we talk about that, so we move to more examples, more examples, because I want you to understand much about permutation. So stay tuned for examples. Okay, so in this example, now we say find the number of permutation of the letters of the names Monica, Benue, Happy. So when you look at this, let's move straight to the solution without taking much of your time. We say solution. The permutation of the name Monica. Monica, if you can see, Monica. Monica has how many words? How many alphabets? One, two, three, four, five, six. And no alphabet is repeated. So we can say we have 6 factorial. Because we have 1, 2, 3, 4, 5, 6. So 6 factorial is equals to 6 times 5 times 4 times 3 times 2 times 1, which it will give you this times this 30 times 4, 120, 120 times 3, like that and like that, then you get the answer. You press your calculator, then you get the final answer without taking much of your time. So here again, we say the name Benue. We say 2 now, we say Benue. The permutation of Benue, Benue has the 2E. We have 2E's there now. So let's assume the E's are different. So we label this one 1 and this one 2. So these 2E can be, they have 2 ways of arranging them. Either this one will be here or this one will be here. We have 2 ways. So this one we say we have 2 E's, and here we have 1, 2, 3, 4, 5, and we say these ones are different, the E's are different. So the permutation of this now we have 1, 2, 3, 4, 5. So it will be 5 factorial all over 2 factorial, because we have 2 ways, that is 2 ways of arranging these E's are the same. So it will be 5 factorial all over 2. We assume these E's are different. So it will be 5 factorial all over the 2 factorial for the E's. So it will give you 5 times 4 times 3 times 2 factorial all over 2 factorial. So this 2 factorial, we cancel this 2 factorial. So this 2 factorial, we cancel this 2 factorial. And here we have this 2 factorial, we cancel this 2 factorial. And here we have 5 times 4 times 3. So 5 times 4, it gives you 20. 20 times 3, it gives you 60 ways. So you will try for the number 3, you will try that when watching. You pause the video, then try the one for the happy. Happy. Happy has 4 letter words. No one is repeating, so it will be 4 factorial. And 4 factorial, 4 times 3 times 2 times 1. This times this is equals to 24 ways. So we have much examples. We say, like example, let me give you another example. You try that on your own. Let's say in a Premier League which has 20 clubs, and if the clubs are to play home and away matches, home and away basis, how many matches are they possible for them to play? How many matches in Premier League? Premier League has 20 clubs. You have Man U, Chelsea, Liverpool, Man City, Leicester, and the rest. So if they are to play home and away on home and away basis, how many matches are possible for them to play? So for that example now, I will not write it, but you do it your way. How possible is them? So since they have 20 matches, that will be 20 permutation 2. That is 2 is for home and away. And when you press your calculator 20 permutation 2, you will get the answer. And the answer is the number of matches they will play in the Premier Leagues. So permutation is very important. It's very important. I will give you one last example on permutation. Then on this very part of permutation, then we move to the cyclic permutation. So this example. So as I earlier explained about 20 Premier League playing home and away, and we said it's 20 permutation 2, and we say 20 times 19 times 18 factorial, 20 minus 2 factorial, which it gives you 20 times 19 times 18 factorial over 18 factorial, and this 18 factorial cancel this 18 factorial. We have 20 times 19, and they give you 380 ways. For you, the football fans, you can check how many matches are being played. So we look at this example again. We say find the number of ways first, second, and third position can be taken by 10 candidates in a semester's exams, assuming there must be no tie. So this question is very straightforward. And we say solution. We're talking about 10 candidates in a semester. And we are talking about ways first, second, and third. That means we have 3. There 3 times that is we have solution here. And the solution, we say the number of ways will be the number of the number of ways will be 10 permutation 3 equals to, that is 10 permutation 3 now is equals to 10 factorial all over 10 minus 3 factorial, which is equals to 10 factorial all over 7 factorial equals to 10
10
times
times
8
9
times
times 8
7
times 7
factorial
factorial
all
all over
over
7
7
factorial.
factorial. This
So we
7
have 7
factorial, we cancel
factorial is equal
this.
to 7 factorial.
This 7 factorial, we
So
cancel
there is a
this. We
mistake
have
here. You can
10
correct
times
the
8,
mistake.
which
It's
is
not 80, but it's
80.
720. 720 ways. That is
So from here,
7
we
factorial
move to the
times.
cyclic permutation. And when we say, let me say, here we move to the cyclic permutation. Cyclic permutation. And cyclic permutation, when you say cyclic permutation, is in cyclic permutation, we are concerned about arrangement of things in a circular object. Arrangement of things in a circular object, maybe arrangement of things in a round table. So from there, we say the number of ways of doing this, the number of ways of doing this, the number of ways of doing this is 1 times n minus 1 factorial. That's the explanation here. When we have n, the number of people sitting in a circular, since it's a round table, it doesn't have the beginning and the end, it doesn't have the starting point and the ending point. You put one person fixed, then you permutate the other. When I give you the example, you will understand it better. Okay, so as an example, in how many ways can 6 members of the Benue State House of Assembly be seated round a circular table? In how many? That is question mark. Then we say solution. Since it's a round table, as I earlier said, so um, we first the number of ways the number of ways the the 6 members of Benue 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 State House of Assembly. Benue State House of Assembly be seated in a circular table will be equals to, since it's 6, I will say is 1 times n minus 1 factorial, and our n is here is 6. So here our n here is 6. Our n is 6. So here we say 1. This one now is fixed, since it's a circular distance, as I earlier said, is fixed. Then here will be 1 times n, that is will be 1 times 6 minus 1, which is 5 factorial. It's the same thing as 5 factorial will be 5 factorial will be equals to 5 times 4 times 3 times 2 times 1. And here will be 5 times 4 is 20, 20 times this 60, 61, 20, which will be 120 ways. So we look at many other examples randomly, but this one is very important. I will not forget, in how many ways can 7 beats. Okay, okay. So now we say, in this example, now we say, in how many ways can 7 beads of different colors be threaded in a circular ring? So in this one, we say solution. We say this is a cyclic permutation, as you all know. So seven things round a ring which can be turned over. There is seven things round a ring which can be turned over. So in this situation, we have it will be 1 times 7 minus 1 all factorial over 2, which is equals to 6 factorial all over 2. And don't be confused when I'm dividing this by 2. When it is turnover, I will show you the formula. When it is turnover, you divide it by 2. So it's seven things round a ring which can be turned over. So this one will be divided by 2. That's why we are dividing this one by 2. So here will be equals to 6, 6 times 5 times 4 times 3 times 2 times 1 all over 2. So when you use your calculator, you get the final answer. So the final example now will be this one is we call this the permutation involving indistinguishable objects. Indistinguishable objects. So from here, without speaking much grammar, I'll give you an example that involves that, which may be for the permutation of the name. Example, to find the permutation of the letter of the name Adika. So in the indistinguishable this thing, we assume the A's to be different. So here we will ever this one to be A1, A2, and A3. And there are situations where the A's will be written. We are writing again, that we say solution. So when we say A1, the A's are different. So here will be A2 and here will be A3. So when you are writing it again here, will be A2 and here will be A1 and here will be A3. You are writing it again, it will be A3 is A3, here D, K, here will be A2, here will be A1, here will be A2. So it can also be written as A3, D, A, K, A2, A1. It can also be written as A1, D, A1, D, E, K, A3, A2. It can also be written as A2, A2, D, E, K, A3, and A1. So these A's will be written in how many ways? 1, 2, 3, 4, 5, 6. That is 6 in 6 ways. That is the A's for the 3 A's. 3 A's will be written in 6 ways, which is equivalent to 3 factorial. But the name here is Adika has how many letters? 1, 2, 3, 4, 5, 6. So now we have 6, sorry, we have 6 factorial all over 3 factorial, which is equals to 6 times 5 times 4 times 3 factorial over 3 factorial. This 3 factorial will go with this. You have 6 times 5 times 4. Which 6 times 5 will give you 30. 30 times 4 will give you 120, which 120 ways. So, for watching that video. Please don't forget to subscribe to my YouTube channel, Adika Mathematical Solutions. Follow me on Facebook and Instagram for more examples. Mathematics is very sweet. It's just for you to pay attention. Share my videos to go around the world to meet some people that are in need of such knowledge. Please don't forget to do it. I'll be taking you people in combination, matrix, differentiation, and integration. These are the topics people send to me that I find it very difficult. Nonetheless, I'll still handle other topics. Thank you for watching. Thank you. Thank you. Bye.